Hi everyone, welcome back to Geekle Node.js online conference. This is our first huge online conference, but not the first that we are doing already. We're getting some experience. Today we've got Sebastian Curland, a father, husband, and experienced developer. Currently is working as a senior full stack developer and security champion at Nielsen. Today, the topic would be about Node.js from single thread to worker threads. Sebastian, welcome to the stream.
Yeah.
How are you?
Fine, very well. How are you?
Yeah, brilliant. That's my second online conference already. How about you? Did you participate in online conferences before?
No, it's not my first online conference, so I'm very excited.
Congratulations, Dan. You're the second speaker today who has the first online conference ever. So tell us a few words about yourself, just a quick introduction to the people that are watching you, and then we can start.
Okay, yep. I'm Sebastian Curland. I'm a senior developer at Nielsen in the Tel Aviv office. I'm originally from Argentina. I've been developing since the 90s, so I have a lot of experience. I usually work with Node.js and I speak in local meetups and some international conferences about Node.js. I'm very excited to be part of this Node.js Global Summit.
Thank you, Sebastian. By the way, could you quickly describe what's your topic about, just in a few words, so that...
Yeah, sure. Sure. Today's session will be about worker threads. This is a new module in Node.js, and it will be like an introduction to the API, and I will show also some code examples.
Thank you, Sebastian. Right. So I'm enabling now you to the mainstream. Your side notes will be there. And then I'll let you know at the end of the time, I'll let you know that 5 minutes left, 2 minutes left, 1 minute left.
Sure.
Perfect. Thank you. Let me enable yourself, and I'm going up.
Okay. Hi, guys. Thanks for joining me in this session about worker threads. So I'm Sebastian Curland, a senior developer at Nielsen in the Tel Aviv office, originally from Argentina. So this is a picture of me with Maradona, if you know Maradona. You can follow me on social networks. And today's session, again, will be an introduction of the worker threads module that we have in Node.js. We will see the API, we will see some core examples, and hopefully at the end of the session, you will be able to start using this worker threads module. Okay, so let's start. Okay, so a typical Node.js application runs on a single process. And there is one thread to run our JavaScript code, because JavaScript is single-threaded. And for that application, there will be an instance of V8, which is Google's JavaScript engine, an instance of libuv, okay, which gives Node.js the event loop and the ability to run I/O asynchronously, and an instance of Node.js, okay? And when I'm saying that we have only one thread to run JavaScript, I'm not talking about the other threads that we have inside libuv that libuv used to run this I/O asynchronously, okay? So for our code, we have one single thread. So with JavaScript and the event loop, we have this problem that if we want to run CPU-intensive tasks, right, then the event loop will be blocked with that task. And if we have other tasks pending, then they will need to wait until the task currently the event loop completes, right? So if you have like a web server and there are some requests, and as part of one of the requests, you are doing some big heavy stuff, some CPU-intensive operation, then the other request will need to wait, right? So there is like this golden rule, which is don't block the event loop. And what if you still want to run CPU-intensive tasks, right? Because sometimes that is what we need to do, okay? Maybe we need to run some crypto or do some heavy calculation. So let's see what were the options before worker threads that you can still use, of course, but okay, so the first one is set immediate that we have in Node.js. So without going into too much detail, the event loop is divided into phases, right? And if there is a long synchronous task running in one of the phases, then the event loop will block and it won't move to the next phases. But if we can split the code into smaller synchronous blocks and run those blocks using this set immediate function, then this will cause the event loop to move to the next phases, okay? And it won't block, okay? The problem with this workaround is that it's not always possible, right? Because maybe it's good for simple cases where the code is simple, but it's not always possible to do this workaround. And also the code can get a bit complicated. So there is another approach, which is probably more common, which is offloading the CPU intensive task to a different process. And we have two modules in Node.js to create new processes. One is the child process model, and the other one is the cluster model. Okay. So when we create processes, so for each process that we create, we will have one single thread to run the JavaScript code of that thread. And we will have also an instance of V8, an instance of libuv, and an instance of Node.js for every process that we create. So if the event loop of one of the processes is doing some CPU intensive operation, it won't impact the event loop of the other processes, okay? And there are some drawbacks when using child processes. First, creating processes is not cheap, right? Because the operating system needs to allocate resources for those processes. And also, as we saw from the previous slide, we need to create an instance for libuv, an instance for V8, an instance for a node, and that can take some milliseconds, some additional time for all the setup. Another thing is that if you need to pass data between processes, so the data will be cloned, okay? And that potentially can be an issue if you want to pass large data, okay? If you have a large amount of data that you need to pass to another process, then can be an issue in terms of memory, okay? And then we have worker threads. This is the slide where you need to clap, okay? So worker threads module was added to Node 10 as experimental, and it became stable in Node 12, okay? So let's now explore this, the API of worker threads, and let's see some code examples. Okay, an application using worker threads, it looks like this. So for each worker thread that we create, we also need to create an instance of V8, an instance of libuv, and an instance of Node, similar of what we saw with child processes. But in this case, with worker threads, everything is running under the same process, okay? And because we create new instances of V8 and libuv and Node, so we have this isolation, and we have for each thread its own event loop, okay? And everything running on one thread won't impact on the other threads. Good, so let's see our first example. So we need to require the worker threads, okay? We get the worker object, and then we create a new instance of the worker, where we pass as the first argument the path of the file name where we have the code that we want to run in the worker threads, okay? So in this case, we have some worker.js file with some code, and that code will be run in the worker thread. And then we can subscribe to the message event to get messages from the worker, and we can use the post message method to send messages to the worker. So I will talk in more detail about this post message method later on. Okay, but this is the way that we can communicate with the worker threads. Okay, subscribing to the message event and using the post message method. Then, if we look at the code in the worker, so we get this parent port from the API that we can use to also subscribe to the message event to get messages from the main thread, and we can use the post message on this parent port to send messages to the main thread. Okay, so Here we use the worker instance and the parent port to create a communication between a worker, a main thread, and a worker thread. So if we don't want to create separate files to run in the worker thread, we can use the same file as the main thread. So as you can see here in this example, I'm just, when I create the new worker, I'm just passing the same file name, okay? So then you need a way to know if you are running in the main thread or you are running in the worker thread, okay? So this is this main thread variable from the worker threads API. So the code that we have in the if statement will run in the main thread, and the code that we have in the else statement will run in the worker thread, okay? And also we have a thread ID that we can use. It's a unique ID for each worker thread that we create under the same process, okay? So each worker will get a unique ID, and we can use that maybe to keep some state of the worker threads or whatever we need to do with that. Great, so let's take a look at the events that we have for this worker instance. We already saw the message event to get messages from the worker event for the worker thread. We have also an exit event to know if the worker has stopped. Okay, so it will be triggered if the worker has stopped. Then we have another event to know if there was an uncut exception in the worker thread, this error event. And the last event is the online event that will be triggered when the worker thread started to execute JavaScript code, okay? So maybe in some cases you need to know that, and you can use this event. Great, so what makes worker threads special? Let's see some cool features of this module and this API. Okay, number one, worker options. So we saw from previous example that when we create a new worker instance, we need to pass the path of the file name with the code that we want to run in the worker thread. Okay, there is a second argument which is optional, and here we can pass some options to the new worker that we are creating. So let's see which options we can use. The first one is worker data. So if you need to pass some initial data to the worker thread, then you can use this worker data in the options object. So in this case, for example, I'm just passing the string hello to the worker thread. And then this worker data is also accessible in the worker thread. So I can require this worker data and just use the data that I'm getting from the main thread. And in this case, I'm just passing a string, and this string or the data that we'll use here in the worker data option will be cloned, okay? It's important also to keep in mind. We'll talk about it in another slide later. Okay, there is another option, the env option. So by default, the main thread and worker threads do not share the environment variables. So in this case, as you can see, in the else statement that will run in a worker thread, I'm setting a new variable with the value of foo. But then if I try to access that variable in the main thread, it will be undefined, okay? So in this case, we can use the env option and use this share n value from the API. And that will tell the main thread and the worker thread to share the same environment variables. So in this case, again, we are setting this variable in the worker thread. And now, because we are using this option, we can access it in the worker thread. Okay, there is another option, the eval option. So sometimes you have like a very small code that you want to run in the worker threads, and you don't want to create a separate file, or maybe you have like a single line of code. So you can use the first argument instead of using it for the path of the file that you want to run. Then you can put here some JavaScript code. And if the eval option is true, then that code will be interpreted and it will be executed. Okay, so I don't know, maybe it's not very useful, but maybe if you have some small examples that you want to run, or again, single line code that you want to run on a worker thread, then you can use this eval option. And another option is the resource limit. So we can send some limits to the worker thread. And once the worker thread reach that limit, it will just terminate. So the limits that the API currently supports are related to the memory. So for example, in this code example, I'm just setting a maximum size for the heap memory to 5 megabytes, okay? And then if the worker thread reach to that limit, it will terminate, and you will see an error like this saying that worker out of memory and worker terminated due to reaching memory limit. Okay, there are all other resource limits, again related to memory, and you can see that in the official documentation. Great. Number 2 in our list. So we have this message channel object that represents the communication channel between threads. Okay. So when we create a new instance of this message channel, there is no method on the message channel object, and we only get 2 ports. Okay. Each port represents an end of this message channel. Okay. So here we are creating a new message channel object, and we are getting the 2 ports, port 1 and port 2. Those ports are actually instances of message port, another object from worker threads API. And we can use this port actually to create the communication between threads, because the events like the message event and the post message method are part of these message ports. Okay. And we saw from previous examples that when we create a new worker, we created the communication with the worker thread using the parent port. So under the hood, Node.js is creating a message channel between this worker and the worker thread. I mean, between the main thread and the worker thread. And the worker and the parent port are actually instances of message port. Okay, so that's why we had the message event and the post message method on the worker and on the parent port. So we talked a bit about message port. I want to talk in more details how actually the communication between threads is being done. Message port, as we said, is used actually to transfer the data between the workers, and it extends the event emitter from Node.js. So we already saw that we have the message event to get messages when the post message method is invoked. And we have also a close event that will be emitted once the channel has been disconnected, or if one of the ports invoked the close method. And then we have this post message event that I want to talk about. So we saw that the post message method, it's used to send data to a different worker thread, right? We send an example where we send, for example, a string using this value, but then we have a second option, which is optional, and it's a transfer list, okay? What does it mean? So we have basically 3 ways to pass data between threads. One is by cloning the data. And the second one is by transferring the data, or transferring the memory that holds the data. And the third one is by sharing the same data or sharing the same memory space that holds the data. So maybe you ask yourself whether you can use or decide what to use in all the cases. So the answer is no. There are some limitations, and you cannot decide what to use. Okay, so let's see the difference now. Okay, so when you use the post message with a value like we saw with the string, so the data will be cloned, okay? unless you are using a shared array buffer that I will talk about in a different slide. But when you use it with any JavaScript type, like primitive, string, numbers, map, set, even array buffers or JSON objects, then the data will be cloned, okay? And also if you have JSON objects, it also support circular references in the objects. So we talk about child process. So in child process, for example, the API does not support circular references. Okay, in this case, it's supported. And again, the data will be cloned. It will be cloned using the JavaScript algorithm, the structure clone algorithm. Okay, there is a standard for that algorithm. And you need to keep in mind that the more complex the data that you are cloning, the more time it will take to clone it, right? Because the algorithm, I think it's a recursive algorithm. So if you have a large amount of data, it will take more time to clone it, okay? So you need to keep it in mind. There is some blog post that I found on the internet from this guy, I think from Google, that he measures the performance of the post message method. And he measures how much it takes to clone 1,000 objects, JSON objects, with a different different amount of property from 1 to 6, different depth in that object, so different nested levels for the objects, also from 1 to 6. So you can see in this chart that, for example, it took like for objects with the 6 nested level and 6 properties, it took around 47 milliseconds, and the file was around 10 megabytes. Okay, and if the file had only, I don't know, 5 properties instead of 6, it take like around 7 milliseconds. Okay, so you need to again to keep it in mind when you work with large objects. So the second way to pass data between workers is by transferring the data, okay? So there are only 2 types of data that you can transfer to a different worker: array buffer and message ports, okay? And once you transfer the data to the second worker, that data won't be usable anymore on the sending side. And that's because you want to avoid synchronization issues and race conditions, okay? And maybe you ask yourself, why do you want to transfer message ports? So the reason is that maybe because you can, by transferring message ports or by sending message ports to different workers, you can create a communication between different workers, not just between a main thread and a worker thread, but between different worker threads. And let's see an example of that. So let's say we have our main thread, okay, and we create 2 workers, worker 1 and worker 2, and then the main thread can communicate with the workers using the worker instance and the parent port, okay? But then if we want to create a communication between worker 1 and worker 2, how can we do that? So we can create a message channel, okay? And then the message channel, as we already saw, it gives us 2 ports, and we can send those ports to worker 1 and worker 2, and then can just use those ports for the communication between them. So if we put this in code, so we create our 2 workers, the worker 1 and worker 2, and then we create our communication channel, this message channel with that gives us the port 1 and port 2. Here in the main thread, we subscribe to the message event to be able to get messages from the workers, okay? So in this case, the main thread will be able to get the messages from worker 1 and worker 2. And then we send to each of the workers the port that we created and also the ID. And just take a look that I'm sending the port also in the value, okay, in the object, in the value argument, and also in the transfer list. So when we transfer something, an array buffer or a message port, we need to put it in the value and in the transfer list, otherwise it won't work. So we are sending to worker 1 the port 1, to worker 2 port 2, and then the code of the worker. So we can just at the beginning send a message to our parent, the main thread, saying hi parent, and then we can get the message that we got from the main thread. We get the port, okay, and then we can use that port to send messages to the other workers. So if I'm in worker 1, I can get the port and use the post message to send some message to worker 2. And then also I can subscribe to the message event on that port to get messages from the other worker. So in this way, we are creating the communication between the two workers. So if we run this simple program, so we can see that the main thread got the messages from the worker thread, and also each of the workers gets a message from the other worker. Great. So another thing special in this worker thread module is that we can share memory. So we can share actually data. And again, in child process, we cannot share data. We can only clone the data when we pass data to a different process. So in this case, with worker thread, we can share data, and we can do it by using the shared array buffer. So what is an array buffer? So it's like the byte array in JavaScript. It's an array of fixed length of binary data. And we cannot manipulate this array directly. So we cannot store or read directly from an array buffer. We need to create some other thing on top of that array buffer. So we can use the type arrays that we have in JavaScript, like the int32 array. Okay, and we can create this on top of the array buffer, and in that way we will be able to read and to store values in the array. A shared array buffer, it's like an array buffer, but for shared memory. It's simple as that, okay? So let's see a small example. So here we create our worker thread, and then we create a shared array buffer with fixed length, and we create our type array, in this case, an int32 array on top of the shared array buffer. And then when we use the post message method, we can just pass this array to the worker thread, and it means that the data of this array will be shared between the two workers. Okay, and as you can see, I'm not using any transfer list because I'm not transferring this array. I'm just sharing it. So, and because it's a shared array buffer, the API knows that it will be a shared array, a shared data type between the worker threads. Great. Another good thing that we have in this in the worker threads module is that it supports the JavaScript atomics module. So we can have atomics in worker threads, and let's see why it's important to have this atomics module. So the problem when we use shared memory or shared array buffer is that there can be a synchronization problem between different threads. We're going to have race conditions when two threads tries to store a value or read some value from the same array, okay? And we don't want those race conditions. So we need a way to do atomic operations on the array. And this is when this atomics module comes in handy, okay? We can use it to do atomic operations on the array. Some of the things that we can do with the atomics, I'm not showing all the things in this slide, so you can check the atomics documentation, but we have the wait and notify method that works.
5 minutes left.
Okay, so We have this wait and notify that work on specific indexes on the array. We have the store and load to put some value and to load some value. And we have also atomic bitwise operations. So let's see a small example. So we create this shared array buffer, and then the int32 array on top of that. We share this array buffer with the worker thread, but then we use atomic weight on index 10. That it means that it will look at index 10 of the array. If it has the value of 0 that we are using here in this example, then it will go to sleep. And the console log that we have behind the atomic weight, it won't execute. Okay, and it will. This main thread will sleep until we have until someone calls notify on the same index, or until we have a timeout. So we have an additional argument that I'm not using here in the wait method, that you can specify a timeout for this wait operation. And then in the worker thread, I'm just as an example storing some value in index 10, and then I'm calling notify on index 10. And after I call the notify, then the main thread will awake and will do the console log. Great, some recommendations. First of all, you need to use thread pools, because there is some overhead in creating the threads. As you saw, there are new instances of V8, libviv, and Node.js. So just use thread pools to reuse the workers that you create, and just don't use a worker thread for parallelizing I/O, because that's what the event loop and Node do very well. So you won't gain any benefit on doing that in worker threads. And please check, I highly recommend to check the official docs. All the things that I put in these slides, you can find also in the official documentation of worker threads. One last example, I will go very fast. So this is a Sudoku solver that we want to run on a worker thread. This is an example from Anna Henningsen, one of the Node core maintainer. She's also one of the responsible for having these worker thread modules in Node.js. So a lot of credit to her. And the idea is to create a very simple HTTP server that gets an input from the input of the Sudoku and just output the solved Sudoku. So the code of the worker is very simple. We have an algorithm to solve the Sudoku in some solve Sudoku JavaScript. You can check the GitHub repository and see the algorithm to solve the Sudoku. But then in this worker, when we get the input from the main thread, we call the solve solution function, and then we post back to the main thread the solution. In the server, we create a worker pool. In this case, we have 4 worker pools. Okay, so if you have like someone calls to the server 5 requests at the same time, then the fifth request will need to wait. So we have a waiting array also to store the waiting request. Then we get the gate. This is our server. We get the data from the input, and then we check if there is any worker thread available in the pool. We call to the handle request. We take one of the workers from the pool, and we call to this handle request function that we will see in the next slide. And if there is no worker available, then we will push to the waiting array a function that once it gets a worker, it will call to the handle request. And this handle request, we first send the Sudoku data to the worker. And once we get the message, it means that we got the solution, and we send it back to the client. And once we finish solving this Sudoku, then we check if there is something in the waiting list. If yes, we take it from the list and we call to this handle request with the current worker. We are not creating a new worker. And if there is nothing pending in the waiting list, we just put back the worker in the worker pool. Okay, so you can check this example in Anna's repository in GitHub. Okay, and I think that's all. Thank you very much. If you have questions, we'll have the Q&A session after the next session. You can always also follow me on social network. Thank you very much.
Thank you, Sebastian. That was an amazing session. You are very well prepared. And by the way, I have to mention that it was just a perfect timing. Amazing one.
Thank you.
What's your feedback about your first online conference?
Oh, it was cool. I mean, thank you for having me. I had some connection issues at the beginning, but finally, I think everything went well. So yeah, so I'm more relieved now.
Thank you. Congratulations. And I hope that you will enjoy more and more online conferences. Well, we are all going to the future, so there's no way back.
Yeah.
Okay,
Sure.
that was Sebastian Curland. And thanks to everyone who is watching. We are moving now to our next speaker. And